Okay, let's do some section 2.2 from the ZIL book, separable or separation of variables problems. So we'll start with a simple one. Say we have dy dx equals sine of 5x. So the idea here is we're just going to take the antiderivative with respect to dx of both sides. You can't just throw integrals around. Remember, these symbols are always tied together. You'll never in your life write an integral symbol without having a differential after it. So technically what we're doing is taking the antiderivative with respect to x of both sides. So antiderivative dy dx equals antiderivative sine 5x dx. But this is just chain rule here. Dy dx dx is just dy. So what we end up doing, the net result here is we end up integrating the left side with respect to y and the right side with respect to x. So just the antiderivative of dy is y. Antiderivative of sine of 5x is negative cos 5x over 5 plus c. And we're done. Okay, what if we had a more complicated example? So I've got here x dy dx equals 4y. So the idea here, the goal, remember differentials are not algebraic quantities. We really can't multiply or divide by them. This is not really a fraction. That doesn't really say dy divided by dx. But it turns out we can pretend, using calculus, we can pretend this is a fraction and we can multiply the dx over. And we can pretend this dy is an algebraic quantity. So our goal here is to get all the y's over on the left side and all the x's to the right side. So I've brought the dx up. I've brought this x over to the right side by coming to the bottom. The y came to the left side by coming to the bottom. And now all my y's are on the left, all the x's are on the right. We have separated the variables. And then we integrate both sides. We're really doing what we did up here. We're integrating both sides with respect to x. But because of that chain rule thing, really we just throw on an integral symbol. And we end up, at the end of the day, integrating the left, dy, and the right side, dx. So the antiderivative of 1 over y is natural log of the absolute value of y. The antiderivative of 4 over x is 4 ln absolute value of x plus c. Don't forget the plus c. Always throw on your plus c on the x side. And technically we're done. This is a solution. This is an implicit solution. It's a relationship between y and x in an equation. That's an implicit solution. But I want to solve this explicitly. So in order to get rid of this natural log, we're going to make both sides powers of e. E to the ln of absolute value of y. The e and the ln cancel out. We get absolute value of y. Over here, we're going to play with logs and exponentials. So remember, when you're multiplying like bases, that's adding the exponents. So working backwards, e raised to all this stuff would be e to the first one times e to c. E to the c, remember c is just an arbitrary constant here. It's our constant of integration. E to the c is just another constant. So I'm just going to call this thing here, I could give it a new name. I could call it C2 or something, but it doesn't really matter. A constant's a constant. So I'm just going to absorb all that together into this constant. I called it capital C. It doesn't matter. I could have called it K or whatever. Now, this 4 can come inside. Remember rules of logs. A number outside can be made the power inside. So that's natural log of absolute value of x to the fourth. Well, x to the fourth is always positive, so those absolute values aren't doing anything. And we get e to the ln of x to the fourth. That's just x to the fourth. So here's my explicit solution. A bunch of algebra happened here. Make sure you understand all of that. Now, it's a good idea to go back and check this. Make sure this does work. So you try that now. Pause the video, take this solution and check it in this original DE here and make sure it does work.